Specific heat. Specific heat is the characteristic of material. It's not going to depend on the dimension like length, area, volume, shape, size, etc. It is intrinsic property of the material. When a body of mass m is heated by delta theta, that means the temperature increases by delta theta in that case, the heat required will be given by this relation m s delta theta. S I have chosen for specific heat. For this, sometimes letter C is also used. So, this specific heat could be given as Q upon m delta theta. Its unit is going to be calorie per gram Celsius, or in SI, you see, joule per kilogram per Kelvin. It's very obvious from this relation that if a body has greater specific heat, it will require more amount of heat for the same temperature. Or other way you could say, when equal amount of heat is given, the body with greater specific heat will show a little change in temperature. And vice versa is the case with the lower specific heat. If the body has lower specific heat, a small amount of heat transfer will also make significant change in temperature. You see, Dulong-Petit introduced one law that is known as specific heat into atomic weight, that is called Dulong-Petit law. This product always remains constant. This product also suggests that for atomic weight being heavier, specific heat is low. If the choice is that of higher atomic weight, the specific heat will automatically be reduced. If the process that you are choosing is isothermal, thermal means temperature, iso is equal. Isothermal process means no change in temperature, and when delta theta will be taken 0, C would become infinite. Then other process will be adiabatic process. Adiabatic process means no heat transfer, and if no heat transfer is there, Q will be taken 0. In that case, C is going to be 0. So these are the two extreme cases. In isothermal, specific heat is going to be infinite, and in adiabatic process, it's going to be 0. Then one more term is defined, that is called molar specific heat. Molar specific heat will also be given by this relation. You see, this is going to be number of moles. While defining specific heat, we'll say that the heat required by unit mass of a substance in raising its temperature by 1 degree Celsius. But here molar specific heat is going to be defined by the heat required by 1 mole of a substance in raising its temperature by 1 degree. This is molar specific heat. Its unit is going to be calorie per mole Kelvin. In place of gram or kilogram, here we are going to use mole. Then if higher specific heat is there, higher amount of heat will be, greater amount of heat will be required for raising the temperature. You see, in gases, complex gases like steam and CO2, these have highest specific heat. In solids, specific heat is maximum that for lithium. Aluminum is also one of the elements which have higher range of specific heat. That's why if suppose you are put to the situation that many spoons are there and you want to stir the hot tea that is not simply drinkable right now, you want to stir the tea with the spoon, you'll have to pick up one spoon. You are given the choice. Then in that case, there are many spoons: copper, silver, aluminum, gold, iron. But in that case, you are going to choose aluminum because aluminum has the highest specific heat, and that will absorb, that will require more heat for getting hot. That will absorb more amount of heat from the tea, and tea would be cooled easily or earlier by picking aluminum spoon. So these kind of concepts should be in your mind. You see, water has a specific heat very high, rather maximum in liquids, you could say. So water always show very small change in temperature. Suppose morning has taken place, there is sunrise and sun rays are falling on ground and the pond nearby. Both are adjacent, but water will be raising its temperature slowly. Now it is almost noon. Earth has become very hot in the month of summer. But since water has higher specific heat, this will require more amount of heat and it will be gradually changing its temperature. It will be comparatively colder than ground. Water has lagged behind in heating. Similarly, in night time, water will lag behind in cooling, and that way water we have as a natural cooler for general public.